Okay, and here is SOL topic number 4A. We are dealing with complex numbers in this tutorial. The most important part of this lesson is to make sure that our calculator is in the correct mode. When working with complex numbers, we must be in the A plus BI or complex mode. So when you get to the SOL test, you turn your calculator on and push mode first. By default, your calculator will be in the real mode, which means that it can only compute with real numbers. If we go down to this line and select A plus BI, we will do that by pushing enter. Now your calculator is in complex mode and it can compute with complex numbers. All right. So the next thing we need to know is where the imaginary unit, where I is on the calculator. It's hiding above the decimal button. You hit second and then decimal and you have your I. So that means that we can evaluate something like this, quantity 2 plus 3i times quantity 3 minus 7i, right on our calculator simply by typing it in. So I'll do that and I hit second quit. And let's type exactly what we see. I see a parenthesis, and then 2, and then plus, and then 3. I need to pull up the I, and like I said, that's hiding above the decimal, so I'll hit second decimal. Close the parenthesis, open up a new parenthesis, 3 minus 7i. I'll type that right into the calculator, do a quick double check. Yep, that's what I needed. I'll hit enter, and the calculator will perform that operation for me and get 27 minus 5i. Pretty cool. Two other notes for this packet: conjugates. Imaginary solutions will always occur as a pair of numbers called conjugates. If a plus bi is one of our solutions, then a minus bi must also be a solution. Conjugates are pretty easy to identify. The first part, or the real part, stays the same. The imaginary part will change sign from positive to negative or from negative to positive. Those are conjugates, and imaginary solutions will always occur as pairs. Lastly, the powers of I. We're going to divide the exponent that we're given by 4, because this is a pattern of 4, and we will match to one of the following 4 decimals. When we divide the exponent by 4, if we have a decimal of 0.25, that is equivalent to I. A decimal of 0.5 is equivalent to negative 1. A decimal of 0.75 is equivalent to negative I. And if 4 goes in evenly to our exponent and we have no decimal, that is equivalent to 1. Obviously, we will need to memorize this pattern of 4, but once you do, we can use the calculator to divide the exponent by 4 and match it up. Let's look at some examples. Number 1, which is an equivalent form of the following expression? 2 times the square root of negative 9. Well, the square root of negative 9 is an imaginary number, but that's okay because now our calculator can deal with that. We just need to type this in exactly how we see it. 2 times the square root of negative 9, and that is my problem. I'll hit enter. The calculator will do it for me. I get 6i. That's answer choice D. Pretty simple. Let's move on. Number 2, which of these is equivalent to 1? So this is one of the powers of I questions. I'm given 4 different powers of I, and I want to see which one's equivalent to 1. Well, that means, from my notes, that we will have no decimal. When I divide the exponent by 4, I should get no decimal. So let's pull up our calculator, and I'll just start with my first one. My exponent is 24. I'm going to divide by 4. And let's see what my decimal is. Well, it goes in evenly. I don't have a decimal, which means that this must be the answer since there's not supposed to be a decimal. I know the answer is going to be A. But let's keep going just for practice and just to be sure. Let's look at the next exponent, 42. Let's divide 42 by 4. And this time, now I'm not very interested in the 10. What I'm interested in, what's the decimal? And I see 0.5. So this power of I gives me a decimal of 0.5, which from my notes is equivalent to negative 1. So that's why that is not one of our answer choices. Let's look at 66. 66 is my new exponent. Let's divide that by 4. And let's see what I get. You know what? I get the 0.5 again. So that's also equivalent to 0.5, which is equivalent to negative 1. So of course that's not one of our answers. Of course we already knew that. And let's do D. That is an exponent of 82. We'll divide that by 4 because this is a pattern of 4. And same thing, we get a decimal of 0.5, so that is also not one of our answers. And we confirmed that A is our answer. Lastly, let's look at example 3. Simplify 2 plus 3i divided by 1 minus 4i. So you'd think that we could just plug this right into the calculator and see what happens. So let's do that. It is a fraction, so let's try that. We'll do the alpha y equals number 1 to pull up our fraction button. And let's see, our numerator is 2 plus 3i. I'm going to hit the down arrow to go down to the denominator, and the denominator is 1 minus 4i. And I'll hit the right arrow button to get out of there. Yep, that's what I have. And let's hit enter and see what happens. Unfortunately, we're not able to use imaginary numbers, complex numbers, and the fraction button together. So we're going to have to quit that error, and we're going to have to find another way to go. So we're going to have to go back to the old school way of plugging this fraction in using the actual division button. What we must do, though, is put the entire numerator in parentheses and the entire denominator in parentheses. We must use parentheses here. Otherwise, the calculator will not understand what we're trying to do. So let's go back to the calculator. I'm going to type a parenthesis and put 2 plus 3i, and then close the parenthesis, then hit the division, another parenthesis for my denominator, 1 minus 4i, close the parenthesis, and that's the division problem. Let's hit enter and see what the calculator looks like. Okay, I get a bunch of ugly decimals, but that's okay. The calculator can change them to fractions. I'm going to go to math. And then the first option is to change something that can turn to a fraction into a fraction. So that's number 1, and I'll hit enter. And it changes it to this fraction, negative 10/17 plus 11/17 I. So let's write that down. Negative 10/17 plus, what was that? 11/17 I. So this is the answer that the calculator gives, and I'm pretty sure you know which answer choice that's going to be. It doesn't look exactly like answer choice A, but we know that it is A. They have the same denominator, so we could write them together as one big fraction, negative 10 plus 11i all over 17, and that is answer choice A. So the calculator is still very useful for this type of problem. So that's the end of the first half of this tutorial. Let's look at the second half, SOL topic number 4b, properties. We have many properties we need to know, and we need to know them by name. The addition, subtraction, multiplication, and division properties of equality, we use these all the time when we're solving an equation. They say that we can add, subtract, multiply, or divide the same value from each side of an equation. The next set of properties we have some for addition, and we have some for multiplication. Let's start with the commutative property. I almost see the word commute right here at the beginning. And when I think of commute, I think of going from home to work, and then at the end of the day going from work to home. And that's exactly what's happening. From home to work, from work to home, it's different order, but it's the same thing. So we change the order, but we remain the same. A plus B is the same thing as B plus A. Same thing for multiplication. A times B is the same thing as B times A. Notice that the order changes. Our next property, the associative property. I see the word associate in there. You associate with different groups throughout the week. Notice that the order does not change. A, B, C, A, B, C. A, B, C, A, B, C. The order is not changing. What's changing are your grouping symbols. So we change the group. We add A plus B together first, and then add C. And that's the same thing as adding B and C together first, and then adding A. Similar idea with multiplication. We're changing the group, not the order. Next is the identity property. If you keep your own identity, you're not changing. If we're talking addition, we can add 0 to a number and it does not change. A remains the same. Or we can multiply by 1 and A does not change. It remains the same. It keeps its own identity. the identity stays the same. Zero is called the additive identity, and 1 is called the multiplicative identity. They're the numbers that we can either add or multiply to something and not change the value. As opposed to the inverse property, inverse undoes stuff. If we add two opposites, A and negative A, they cancel each other out and we get that additive identity 0. If we multiply two reciprocals, A and 1 divided by A, they cancel each other out by multiplication and we get that multiplicative identity. So inverse property, they undo things. I'll just say undoes stuff. Depends on if we're adding opposites or if we're multiplying reciprocals. The closure property, you don't see the closure property that often, but what that means is the real numbers, the set of real numbers is a closed set. Based on addition, if we add any two real numbers together, we'll get another real number. So it's a closed set. Same thing, it's closed under multiplication as well. If we multiply two numbers together, two real numbers, we will get another real number because the real number set is a closed number set. Okay, let's look at some more properties. Some of these might be familiar. Distributive property, that's probably one of the most used properties we use in algebra, right? Distributive property says if we've got a number multiplied to a set of parentheses, then we multiply it to each part of the parentheses. So that's just distributing the value of A. We multiply it to B and we multiply it to C. You might see the distributive property going backwards this way. That's fine. The trichotomy property, tri means 3, so there's 3 things going on here. If you're comparing two numbers, either they're going to be equal to themselves or to each other, one of them is less than the other, or one of them is greater than the other. Seems pretty simple, but that property has a name, and it's called the trichotomy property. The substitution property. This is a property that we use almost all the time as well, and it says that we may replace a quantity with an equivalent quantity. For example, if we're solving this equation, let's say we have x equals 2 times 10. Well, of course, 2 times 10 is 20, so what I can do is I can replace 2 times 10 with an equivalent expression, which is 20. And that's the substitution property. It's not the multiplicative property, because the multiplicative property says I need to do multiplication to both sides of the equation. This is simple substitution. I'm replacing 2 times 10 with a 20, an equivalent number. And finally, we have our reflexive, symmetric, and transitive properties. Notice the order, R, S, T. They're in alphabetical order. And we start with the simple thing, we go to a more involved thing, and then we go to the most involved thing in order. The reflexive property, you probably reviewed this much in geometry, that anything is equal to itself. And that's a pretty silly property, but it's got to have a name, so it's called the reflexive property. It's like you're looking in a mirror. The symmetric property says that if we have A equals B, then B equals A. Do not get this confused with commutative property. Commutative property is changing the order of the addition or changing the order of the multiplication. The symmetric property is changing around an equal sign. For example, if you came down to an equation and you said that 5 equals to x, we can flip that around and feel a little bit more comfortable with x equals 5. That's an example of the symmetric property. And finally, the transitive property, you looked at this in geometry as well, very similar to the law of syllogism. If A equals B and B equals C, then A equals C. We have that connection right here in the middle so that we can get the beginning and the end together. Let's look at example 4, our one property problem. The steps used to solve an equation are shown. So we've got 5 steps to solving this equation. And the question says, what property justifies the work between step 4 and step 5? So that's the step 4 to step 5. That's right here. So we need to see what's changing and what property would justify that. So step 4 says 1 times r equals 21i. Step 5 says r equals 21i. Well, nothing changed on this side. The only thing that changed is 1 times r was r. And if we multiply by 1 and nothing changes, that must be the identity property of multiplication. Excellent. So that's exactly what we used, the identity property of multiplication. Let's see what happens from step 3 to step 4. I see that 3 halves times 2/3 equals 1. Well, that is our inverse property. They undid each other. We multiplied by the reciprocal. And I see that 14i times 3 halves became 21i. That is substitution. We replaced 14i times 3 halves with an equivalent expression, 21i. Let's see what happened up here in step 2. It looks like we multiplied 3 halves to both sides. So what's happening in this step is the multiplicative property of equality. Because we're multiplying the same thing to both sides, it's the multiplicative property, and because we're doing it in an equation, it's of equality. If we had added something to both sides, it would have been the additive property. If we had subtracted, it would have been the subtractive property, and so on and so forth. Okay, thanks for watching this tutorial, and let's go ahead and do well with our packet.